Good day, everyone. Your favorite uncle here. I don't know where I got this phrase uncle from. But as I promised, I said I would take you through the 2022 May June exam. All right, so I'm going to start with the multiple choice. And for those of you who have not subscribed as yet, please just make sure that you're part of the family. And of course, if you need assistance with mathematics or physical science, you are more than welcome to get in touch with us. Our email address is info@mlungisinkosi.co.za. All right, let me just go through this paper. Hopefully, you are ready to tackle it along with me. All right, let's go through the very first question in multiple choice. And by the way, I'll be answering the questions in stages, so I won't do the entire question paper, but I'll just be posting it one question at a time. Okay, hope that will be okay with you. Right, let's go through multiple choice. They say, a bucket list. A bucket list. Listen to me. A bucket is at rest on a table. Which one of the following is the reaction force of the weight? Okay, of the bucket as described by Newton's third law. Right. Now, I want you to always remember, so when it comes to Newton's third law, the third law, or rather, the third law simply says if body A exerts a force on body B, then body B exerts a force on an equal but opposite force on body A. Now, what is weight? Remember, weight is the force that the earth, exerts on an object. So in this case, we are talking about the bucket, all right? So it's the force that the earth exerts on the bucket. So then if it's earth on bucket, then it has to be bucket on earth, okay? If A on B, then B on A, right? So, which one is... the reaction forces according to Newton's third law, it must be the force that the bucket exerts on the earth. So the correct answer there should be B. All right. Now moving right along, to the next question. Now they say to us a ball is dropped from a small height above the ground. They say ignore air resistance, right? Now, they say to us the following pairs show physical quantities associated with the ball while it is falling on the ground. Okay, so they say in which of these pairs will both quantities change? So we want quantities that will change while the ball is falling, right? Now, I want us to quickly look at it. In this case, so the first one is mechanical energy and weight. Now remember, while the ball is falling, because we're assuming there's no air resistance, right? Or in fact, they told us that. And in this case, so we know that mechanical energy will be conserved. It means mechanical energy will not change, okay? But I mean, also, so does the weight. Of course, we're assuming that the mass of the ball will remain the same. And of course, gravitational acceleration does not change, so the weight does not change as well. Okay. And then for B, kinetic energy. Definitely kinetic energy should change because remember, as it goes down, we know that the ball will actually be increasing in velocity, so as well as kinetic energy, right? But momentum as well. Remember that momentum is dependent on velocity. So it looks like B will be our option. Okay, our choice for quantities that change. Remember, we want two that change, right? Why could it not be C? Let's see. Gravitational acceleration. Remember, that does not change. Okay, while kinetic energy does change, and we wanted two. And then lastly, D, gravitational potential energy. That does change because as the ball goes down, the height changes, all right? Gravitational force does not change. So it does seem that our answer in this particular case, and please, I hope you don't mind the quality of this paper. because I've actually taken just photos of it. So I hope that you will not mind, just the poor quality. All right, but nonetheless, I do know that it will be visible. Right. Okay, so going for the third question, they say a ball is dropped. I like these kind of questions, by the way. A ball is dropped from a height h and strikes the floor with a momentum p. They say to ignore air resistance. They say the ball is now dropped from height 2h. Right. Now, first of all, let's just try and quantify momentum as a function. Okay, right. Let me just get this right. Let me get this working better. Okay. So let's get momentum working, rather momentum as a function of height. Okay. So remember, momentum is mass times velocity, right? So that means that obviously once we get to the bottom of the ball there, okay, I keep trying to increase this thing so that you can see it. So it means that momentum is a function of mass times velocity. But in this case, when the height was h, in fact, let me write this on the left-hand side so that I'll do the other one on the right. Okay, so P is equals to m times v. But what is our velocity when it gets to the bottom? Remember, initial velocity is 0. So we know Vf squared is equals to Vi squared plus 2 times G times delta y, but in this case we know that should be the height, right? So I'm just going to say 2gh. So we know Vi is 0. So it means that Vf, okay, the momentum when it gets to the bottom is the square root, okay? Of course, I won't consider the direction plus or minus or whatever the case is. So it's just going to be the square root of 2gh, right? So in this case, it means that if I were to consider the momentum, it would be mass times that velocity, which is going to be the square root of 2gh. So that's the initial momentum, right? Now, if we increase the height okay, let me just remove this first. So if we increase the height to 2h, then it means that we are now going to have our Vf as being, now please, I want you to note, Vf squared is going to be 2 times g, remember initial velocity is 0, okay, 2 times g, 2g multiplied by 2h, okay? So it means that now we've got 4gh, okay? That's Vf squared. But remember, we're looking for Vf, and in this case, it would be the square root of 4gh. Now, if you don't mind, I want to express it as 2 times 2gh. And the reason for that is that I still want to retain that to some extent. Okay, so we can look at it as square root of 2 times square root of 2gh. So if we have to calculate the momentum, the new momentum P, let's say the new P new or P2, whatever you want to call it, I want to express that in terms of the original P there, right? That's going to be mass times the new velocity, okay, of course, for in this case the new height 2gh, 2h rather. So that's going to be mass, but what is our new velocity? It's going to be square root 2 times the square root of 2gh. Okay, right, I want you to note in this case, so we've got a factor of square root 2 multiplied by m times square root 2gh. I want you to note, what does this represent? Okay, can you see? It's the original P. It's what we have over there. So it means that the new momentum, okay, will simply be the square root of 2 times the original p. So it means that the correct answer there is square root of 2p. The correct answer is B. I hope that makes sense, ladies and gents. That you're able to follow as I answer this question. All right, let's go to the next one. They say object X exerts a gravitational force F on object Y, right? When the distance between the centers of the object is R. Now, as soon as they give you these kind of questions, please, I want you to always note what you're going to do is kind of express. So you've got two objects there. We're assuming that the masses of the objects would stay the same. So it means that force F is equal to G, the mass of 1 times mass of 2, divided by, they said the distance is R, so divided by R squared. Now they say the distance R is now doubled, okay? So meaning, and they say to us, which one of the following represents the gravitational force X now exerts on Y? In fact, I should have said the mass of X times the mass of Y, isn't it? Right? So now we're looking for the new force. Once again, we're looking for the new force. So we know the mass of X stays the same, the mass of Y stays the same, divided by, but what's the new distance? The new distance is 2R, so this is going to be divided by 2R. Remember, it is all squared, right? So in this case, that's going to be G, mass of X, mass of Y, divided by 4R squared. Now, why am I writing it in this way? So I want to try and get it back to what I had originally as F. So I want to express the new force in terms of the old force. And in this case, what's going to happen? So it means that the new force is going to be G, the mass of X, the mass of Y. Okay, now let me do this. In fact, let me remove this 4 at the bottom by multiplying by the inverse. So that's 1 over 4. But what I do at the bottom, I do at the top. So that cancels with that. So this would be 1 over 4 divided gmx my over r squared. Okay. Remember, I've removed that 1 over that 4 that was at the bottom by multiplying by 1 over 4, but I did the same by multiplying by 1 over 4 at the top. So this, remember what this represents. Okay, what does it represent? It represents force F. So this will be 1 over 4 times F. So the correct answer there is A. All right. Hopefully you are still well on track, just following in what I'm doing. Okay, so the next one says a force F moves an object P from point X to Y, to point Y, along different paths, okay, that is 1 and 2. Now, in this case, they want to know the work done by force F in moving the object is the same. So they're saying both of in both scenarios the force F is the same. They say which one of the following can be used to describe force F. Okay, now would force F be the normal force? Would it be the tension? Would it be the gravitational force or the frictional force? Okay, I would say personally, I would think that force F would be the gravitational force. Let me just verify that. Okay, the work done by force F in moving the object is the same. Yes. So in this case, just please note, okay, that you're talking about an object that is at a height h there. So as a result, it means that there will be a force due to gravity that is exerted on the object. So as a result, I truly believe that that should be gravitational force. So that would be D. Okay. Right, and then the next question says, which one of the following can be explained by the Doppler effect? I'm sure many of you would get this one right. They say a stethoscope is used to listen to a person's heart. That's not true. When it comes to the medical use, we usually use a what do they call that, the sauna, when pregnant women go for a sauna. I just forgot that the name of the machine that they use. Okay, that's the one that we use to listen to a baby's heart, not the stethoscope, the ones that doctors use. It doesn't use the Doppler effect, so please just be careful of that. They say an echo is heard from sound waves that are reflected off a cliff. That's not true. In that case, that's simply reflection of sound. The spectrum of light from an approaching star is shifted towards the shorter wavelength. Definitely, we would call this a blue shift, right? In this case, when the star is moving towards the Earth. All right, so let's see. The last one says sound intensity decrease when the sound source moves away from the stationary listener. Definitely not. Please note, when you're talking about intensity of sound, you are talking about the loudness of the sound. That has absolutely nothing to do with the Doppler effect. The Doppler effect has to do with frequency of sound. Okay, right, so C would be the correct answer there. Right, and then 1.7, they say to us we've got two oppositely charged point charges that move towards each other. Which one of the following is correct? Okay, they say the point charges move at a constant velocity. Now remember, let me just so when I've got 2 point charges that are moving closer to each other, I'm trying to just get some more space here. When the point charges are moving closer to each other, right? Remember, as they move closer, the distance gets shorter, and as a result, their force, actually, remember that force is inversely proportional to distance. So as a result, their force increases, and as a result, acceleration also increases, according to Newton's second law, right? So they say the point charges move at, I would just simply choose an increasing acceleration. Okay. Right. In fact, let me just see. So a constant force. Yeah, the forces are increasing, therefore the acceleration is increasing. Yeah. All right. So going to the next question. We're almost done. So they say, which one of the following phrases describes the EMF of a battery? Okay. By definition, the EMF is the maximum energy supplied per unit charge. Just for you to remember this, okay? There's a formula that says V is equal to work done divided by charge. So this is where we get the definition for EMF. Remember, the work done is energy. So it's the total amount of energy per unit of charge, right? Q stands for charge. So in this case, the correct answer would be D in that instance. All right, the next question, they say the graph below represents the output voltage versus time for an AC generator. Okay, and they say the speed of the rotation of the generator's coil is now doubled. Now, please remember, ladies and gents, the moment that you are going to increase speed, because you know that it's minus n change in phi, rather, change in phi, in this case, which is the change in magnetic flux divided by the change in time. Now, the moment you increase rotation, remember that when you increase speed, you are actually decreasing the time it takes for one rotation. So that means that the output EMF should actually increase, right? And as a result, what's going to happen there? They say which one of the combinations shows the correct new peak, right? So that would mean that we would increase the output voltage. At first it was 200, so it should be now double that, so it should be 400. But the speed of rotation, or the time of rotation, has now decreased, because we've doubled the speed. The time would no longer be 0.04 for a full cycle, but it would be 0.02. So I'm looking for 400 and 0.02, and it looks like our correct answer will be A, right? I hope that makes sense to all of us. Okay, and then the final question. All right, now they say to us, a photon of light. Okay, let me just increase that a bit. A photon of light of energy 2x is shone onto a metal surface with work function x joules. Which one of the following represents the maximum kinetic energy of the electron ejected from the metal by this photon? So remember, we've got E is equal to omega 0. So E, this would be the energy of the photon, is equal to omega 0, which is the work function, plus the maximum kinetic energy, right? Now, they told us that the energy of the photon is 2x, so this represents 2x. And they said the work function is x joules, so that should be that there. So we want to find out what EK max would be, and all we simply do is take that to the other side. We've got 2x minus x, which is equal to EK max, and as a result, 2x minus x should give us x, so the correct answer there should be C. It means our maximum kinetic energy would be x in that case. Ladies and gents, I hope those of you who wrote this question paper, you really were able to get all of those answers, right? If you didn't, of course, this is a way of just checking. But for those of you who are preparing, I hope this will be able to help. Okay, I'll continue with question 1 and all the other questions as time goes. Just look out for those posts as they come in. All right. Otherwise, I'll see you guys again next time. Please don't forget to subscribe, and please, we're trying to get to that 100,000, that epic number, right? So please just make sure that you tell as many people as you possibly can. Don't be selfish, man. Tell them about the plug that you guys have in physical science and mathematics, and let this family grow. I'll see you guys next time. Sharp, sharp.